We're rocking with the series on relations and functions. In this video, in a second, I'm going to show you how to find the range of a function when they give you the domain. In the meantime, please make sure you like, share, and subscribe. Do it now. Hit the button. What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring. And I'm back again to drop some more math jewels. In this video, we're going to be given a function and domain values, and we're going to figure out how to produce the range values when you're given the domain. So let's go ahead and get right into the examples. Example one, what we have is if I am the domain, so I'm given the domain 1, 2, 3, and 4. And I'm given the function f of x equals negative 1.5x plus 4. All right, so what I'm going to do is I'm going to actually evaluate this function 4 times, once for each of these domain values, and it's going to give me a corresponding range value, right? So if I want to find f of 1, that equals negative 1.5 times 1 plus 4. F of 1, okay? So that's telling me that I'm going to substitute 1 into x anywhere in the function, right? So negative 1.5 times 1 is negative 1.5, and then we add 4. And that is, I believe, let's see, 4 minus 1.5 is 2.5. So f of 1 equals 2.5. So that's the first range value. So I'm going to just put it over here. I'm going to say range equals, and I totally spelled that wrong, but it's all good. So my range is 2.5, and we're going to get the other values of the range. Let's go ahead and do f of 2. Right here. So f of 2 equals, same thing, negative 1.5. But this time, we're going to multiply it by 2 and add 4. So when you look at this, negative 1.5 times 2 is negative 3. Negative 3 plus 4 is 1. So f of 2 equals 1. So that's my second value in the range. All right. Let's erase these. And please remember, for each corresponding range value, that produces an ordered pair. So you'll see when x equals, when x is 1, y is 2.5. When x is 2, y is 1. So it just makes an ordered pair. The next one, let's say we have f of 3. That equals negative 1.5 times 3. Plus 4. So negative 1.5 times 3 is negative 4.5. So negative 4.5 plus 4 is negative 0.5. So f of 3 is negative 0.5, right? So boom, negative 0.5. And then we'll have the last value, f of 4, which equals negative 1.5 times 4 plus 4. All we're doing is evaluating the function for the given values of the domain, right? So here, that's negative 6 plus 4, which equals f of 4 is negative 2. So boom, negative 2. So when we're given, what this is saying is when I'm given this function, f of x equals negative 1.5x plus 4, and I'm given the domain values of 1, 2, 3, and 4, the corresponding range values are 2.5, 1, negative 0.5, and negative 2. And each domain value corresponds to a specific range value, which creates an ordered pair. All right? In this next example, as you can see, it says the the domain of g of x equals 4x minus 12 is 1, 3, 5, 7. What is the range? So we have the function g of x equals 4x minus 12. We have specific domain values of 1, 3, 5, and 7. And we want to find the range value. So we're just simply evaluating this function g of x. So I want to find g of 1 that equals 4 times 1 minus 12. And I'll go ahead and write g of 3 up here as well. G of 3, not x, g of 3 equals 4 times 3 minus 12. So these are my first two domain values. I'm going to go ahead and evaluate those. 4 times 1 is 4. 4 minus 12 equals negative 8. So g of 1 equals negative 8. All right. And here, 4 times 3 is 12. 12 minus 12 is 0. So g of 3 equals 0. So my first two range values, which we can say, let's use a different color. And we can say R. So the range equals, I don't know why this marker is so squeaky, negative 8, 0, and we'll put the other values up there in just a second. So now let's do g of 5 and g of 7, right? Boom. G of 5 is 4 times 5 minus 12, and g of 7 is 4 times 7 minus 12. Simply evaluating the function. 4 times 5 is 20. 20 minus 12 gives us g of 5 equals 8. 4 times 7 is 28. 28 minus 12 tells me that g of 7 is 16. So my other two values of my range are 8 and 16. So boom, negative 8, 0, 8, and 16, right? Once again, that produces ordered pairs of 1, negative 8, 3, 0, 5, 8, and 7, 16. Each domain value has should have one corresponding value of the range. Well, if it's a relation, if it's a function. So it can have multiple values in the range if it's a relation, but if it's a function, it's only going to have one individual one.